Welcome back. In the last video, I promised a statistics review, and my wife laughed when she heard about that because I didn't do too well in statistics. But we're going to review the normal distribution and learn how to sample it using data table on a blank cell. So as you know, there's such a thing as a normal distribution, and it helps us measure our uncertainty around some variable x. It has a mean and a standard deviation. So let's say I'm trying to measure the uncertainty around my next exam score. Coming into the final exam, and I expect to make pretty close to an 85 on it. But I measure my uncertainty of how much better or worse things could be with a standard deviation of 5. And what that says is there's about a 2/3 chance that I'm going to make a B on that exam. Because the mean plus 1 standard deviation would be a 90. And the mean minus 1 standard deviation would be an 80. Therefore, 68% of the time, if I were able to do this many, many times, I would end up somewhere between an 80 and a 90. About 95% of the time, I'd end up within 2 standard deviations of the mean, which would be a 75 to a 95. And about 99.7% of the time, if I did this a whole lot, I would be between 70 and 100. Now, I probably just butchered almost every term you learned in statistics, so please defer to your statistics teacher and not to me when it comes to this kind of stuff. We're going to get back into Excel, into my comfort zone pretty soon. First, I want to draw another version of this chart called the cumulative probability. The cumulative probability is just adding these probabilities up in a cumulative manner such that we know we have about a 50% chance, exactly a 50% chance of being less than the mean. As I'd mentioned earlier, we have far less than a 1% chance of being less than 3 deviations less than the mean, or let me say more than 3 standard deviations less than the mean. We have about a 2.5% chance of being more than 2 standard deviations below the mean, about a 1/6 chance of being more than a standard deviation below the mean. Again, about a 50-50. We're at 50-50 here. And then 1 standard deviation above the mean, 2 standard deviations above the mean, or 3 standard deviations above the mean. Now, as you know, there are no bounds on this distribution, so we could have an infinitely positive, infinitely negative score, and we'll address that in a couple of videos beyond where we are right now. But for now, let's go over to Excel and see if we can draw this cumulative distribution line. Okay, first let's describe my uncertainty about my exam. There's some mean, and I'm going to do an Alt-I-S for symbol. Come down here and choose mu and hit enter a couple of times. And the mean I said was an 85. That's my best guess at what I'm going to make on the exam. But my standard deviation, the measure of my uncertainty, Alt-I-S sigma, is 5 points. So for each score I mentioned earlier, from a 70 to a 75 up to 100, let's calculate the probability of something less than that score. And let's use a function called norm.dist, which says if you'll tell me the score, the mean, and the standard deviation, and whether you want that to be cumulative, which was the picture I drew on the bottom, or not, which was the picture I drew on the top, you can get either one. But again, we're going to work with cumulatives in Excel here for a while. So I want to get some absolute references on that and that by hitting F4. And then I want to copy that down and do an Alt-HP to change it to a %, Alt-H0 to get a decimal place. And what we see is the chance of being less than a 90 is about 84%, but the chance of being less than a 90 minus the chance of being less than an 80 is 68. So that's where we get that confidence of being within one standard deviation. Would be 68% confident that would be within one standard deviation of the mean. And if we wanted to do the same thing for 2 standard deviations or 3 standard deviations, now let's go the other way. Let's say we had a probability, maybe a 10%, 20%, and we wanted to know what the corresponding score would be. Notice I didn't use 0 or 100 because a normal distribution is unbounded. Let's calculate the score that corresponds to that probability using the norm.inv function. And if we know the probability and the mean of our distribution and the standard deviation of our distribution, then we know the score that corresponds to that probability. And what that says is there's a 10% chance that I'm going to do worse than a 78.6. There's a 50% chance that I'll do worse than an 85. And there's a 90% chance that I'll do worse than a 91.4. Well, let's see if we can make some sense out of all of this boring talk about probabilities and scores. Let's say we were going to take this test 19 times. And so I was just going to roll the dice and get a random number each time. And that random number should work out to a pretty good distribution from 0 to 1 of probabilities. And if I took it 19 times, what would my score be? I'm just going to copy that formula. You can check the math on this if you want. Most of the time, I'm going to get something in the mid-80s. Might get something in the low 80s and only a small fraction of the time in the 70s. Maybe in the high 80s and a very small fraction of the time in the 90s. And so qualitatively, we see that, okay, if we ran a whole lot of simulations here, then most of them would be right around our mean, and then we'd get some in those thin tails. Let's do this again for, let's make these 1% apart, and then we'll get something that we can plot. So let me do this and just copy this down to about 100. Okay, so we have 99 simulations here. I wonder how many of them, I'm going to narrow some of these so we can see a little bit better. I wonder how many of them would be between a, we'll do a 73 to a 74 and so on. This recording lectures thing ahead of time is kind of new to me, so it's not the best thought out, but bear with me. I want to say count the number of times that my score was less than this number. Okay, so out of 99 tries, it was less than a 73 0 times. And let's just divide that by 99 so we get a percentage. And so it looks like there's about a 5% chance I'd have less than a 77. How does that compare over here? That looks reasonable. 15% chance that I would have less than an 80. That looks pretty reasonable. 50% chance that I would have less than an 85. And so on. So let me plot these. Score, that's going to be the X, and cumulative probability is going to be the Y. I'm going to do an Alt-ND, Enter, and get this chart. So this is the Excel version of the lower chart that I drew at the beginning of this video. It says you have a very small chance of getting less than a C, practically none. It says you have about a 50-50 chance of getting an 85. And a very small chance of getting something very close to 100. So look back to the beginning of the video, and we've now recreated that. What I hope you took away from this is that we can build a model that has a mean and a standard deviation and a probability, spelled correctly, and we can calculate a score. And so in this case, let's say the probability, this out of the way, let's say the probability was 10%, and then the score would be norm dot in of the probability, the mean, and the standard deviation. We'll show this as an input, and this is an output. And if you don't remember anything about the rest of this, remember this, that if I expect to make an 85 on my exam, and I have an uncertainty about that I could measure with a standard deviation of 5, and I knew what probability I wanted to plot, then I could come up with a score that goes along with that. So let me copy this sheet, get rid of the chart, get rid of this, and let's do a data table on a blank cell. And let's say I took that exam 100 times. So these are going to be iterations. If you don't remember what that was, refer back to the last video. Iteration. Last video being data table on a blank cell and score. So what do I need to do to make this work? I need to put a random number here. Now does that look familiar to the last video? This becomes an output. I think we said these would be inputs, and when we're doing data tables on a blank cell, I think I made an executive decision without you guys and said let's color it yellow. So when we build this data table on a blank cell, Alt AWT tab, then the column input cell goes into the yellow cell. And so I need to check my calculation options. Excel keeps doing this to me. If your data tables don't work right, go to formulas and change that to automatic instead of automatic except for data tables. We'll talk about that on the first day of class. And so if I took the exam 100 times, this is pretty representative of the outcomes I would get. So if I want to know how many of those were above an 90 or an 80 or a 70 or a 60, I could say count if range, lock it, is greater than and it says I'd have about a 16% chance of an A and 88% chance of at least a B, and for these 100 iterations, 100% chance of at least a C. If I hit F9, I can probably recalculate that. At that time, I did have 1 out of 100 that was less than a C. So remember that initial chart I drew, how thin that tail was down at 70. We have a very small chance there. If we wanted to know the chance of an A or a B or C, I could say equals this minus this. Copy that down. Slow down the video and think about how I did that and why I did that. So I can see what the probability of a certain grade is. And notice it's random, so every time I recalculate the spreadsheet, let me divide that by 100. I want to divide those by 100. One easy way to do that is copy, Alt ESI, Alt HP to change it to a %. Okay, so with 100 simulations, we don't get a great convergence, but it looks like I'm going to have overall about a 15% chance of an A, about an 18% chance of a C. If I hit F9 to recalculate, 17, 19, 15, 19, 16, 16. I can get a pretty good idea of what I should expect, what the possible outcomes might be on this final exam. In the next video, I will review this one very succinctly, and then we'll look at a couple of applications. Perhaps down the road, it might make sense to come back to this video after you've done more Monte Carlo simulation and see kind of what went into it.